How does the Schwarzschild radius define black holes? Imagine a point in space where gravity is so intense that nothing, not even light, can escape. That's what makes black holes such fascinating objects in our universe. But how do scientists determine the size of a black hole? The answer lies in something called the Schwarzschild radius. The Schwarzschild radius is a specific distance from the center of a mass where the escape velocity equals the speed of light. Escape velocity is the speed needed to break free from an object's gravitational pull. For Earth, this speed is about 11.2 kilometers per second. But for a black hole, the escape velocity at the Schwarzschild radius is the speed of light, which is about 300,000 kilometers per second. If you compress a mass into a sphere smaller than its Schwarzschild radius, the gravity becomes so strong that not even light can escape. This is what creates a black hole. Think of it like squeezing a balloon until it's so tiny that the surface becomes a point of no return. Once anything crosses this boundary, called the event horizon, it cannot escape. That's why black holes are invisible. They trap light and matter inside. The size of the Schwarzschild radius depends directly on the mass of the object. For example, the Schwarzschild radius of the Sun is about 3 kilometers. If the Sun's entire mass were squeezed into a sphere smaller than that, it would turn into a black hole. For a much more massive object like a star with 20 times the mass of our Sun, the Schwarzschild radius would be about 60 kilometers. This radius acts as a boundary that marks the edge of the black hole. It's not a physical surface but a point where the gravitational pull becomes so intense that escape becomes impossible. The larger the mass, the bigger the Schwarzschild radius. That means supermassive black holes at the centers of galaxies can have Schwarzschild radii spanning millions of kilometers. Understanding the Schwarzschild radius helps scientists figure out when a star will collapse into a black hole. It also explains why black holes come in different sizes. When a star runs out of fuel and collapses under its own gravity, if it compresses within its Schwarzschild radius, it becomes a black hole. This radius is a key concept in astronomy and space science because it connects the mass of an object to the size of the black hole it can form. In essence, the Schwarzschild radius is the defining line that separates a normal star or planet from a black hole. It tells us how small an object must be for gravity to dominate everything else. It's a simple yet powerful idea that helps us understand some of the most mysterious objects in the universe.